Well, hey there, guys. Mr. Carlson here. Let's talk about names and formulas for ionic compounds. If you look right here, I've got a list of a couple of ionic compounds here. And let's see if we can write the name for these. For ionic compounds, the naming is actually pretty simple. Our rules are this, that the first part of the compound, which is the metal or the cation, the positively charged part of this, that part of the compound, we just use whatever the name from the periodic table is. So Mg, if we go to the periodic table here, Mg is right here. That's magnesium. So I don't have to change anything to that name. I would just write for the name of it, magnesium. But for the second part of it, the anion, if it's a monoatomic anion, so monoatomic meaning it's made up of just one element, so chlorine right here, that's just one. This is just one. These down here, though, these are polyatomic. Those have a little bit different rules. But if it's just one thing like that, just one element, then what we would do is we would change the ending of the name to "ide." So I've got chlorine here. So in this ionic compound, I wouldn't call it magnesium chlorine. It would be called magnesium chloride. And that would be the name of this. So magnesium chloride. Same thing here. I've got sodium attached to iodine. So for the metal, for the positive part, just sodium. And then for the second part, since it's just monoatomic, I'm going to call it, instead of iodine, iodide, making it end in that "ide" right there. So iodide. So anytime we have something from the periodic table, so if you have something bonded to oxygen, it would be called an oxide. If it's bonded to sulfur, it would be sulfide. If it's bonded to phosphorus, it'd be called phosphide. If it's bonded to just nitrogen, it's nitride. Fluoride, chloride, bromide, iodide. So we change the ending of those to end in "ide." Now again, that's only if it's bonded to that element on its own. If, however, whoops, wrong screen. If, however, it's bonded to something like this. So if you see a compound where this metal is bonded to like a group of elements like this, well, that we would have to go to that list that I handed out to you. It's that list of polyatomic ions. You'd have to look up what the name of this is, and you'd have to use the name from that list. So you don't do anything to the to change it to "ide" or anything like that. Some of these will already end in "ide", but you don't have to change the names of the polyatomic ions like you have to change here. So for this one, I've got beryllium. Let's see, beryllium. I think that's how you spell it. And then I've got an OH, and I've actually got two OHs that this is bonded to. But I'd have to go to that list of common polyatomic ions, and you have to look for OH on that list. And if you find it, you'll see that it's called hydroxide. OH is called hydroxide. And so the name of this is called beryllium hydroxide. Let's try this one. I've got aluminum, two aluminum atoms, or ions, I should say, attached to three sulfate ions. So SO4, again, you'd find that on your list of polyatomic ions. And so the name of this would just be aluminum sulfate. So that's how we would write the names for these. We would just write what the name of the metal is without changing the name. And then for this anion here, we change it to "ide" if it's an element by itself. But if it's a polyatomic ion, we just use the name from the list. Now, what about writing formulas for these? So like if we're given the name and we have to write out what the formula is. So what we have to make sure we do here is we have to make sure that we balance out the charges. So let me go back up here for a second. What I mean by writing out formulas is writing these. So when we write these formulas, what we're doing is what we're trying to figure out is how many of each of these ions do I need? So like this aluminum sulfate here, there's 2 aluminums attached to 3 sulfates. In this one, there's 2 hydroxides attached to 1 beryllium ion. For NaI, there's only 1 iodide ion attached to 1 sodium ion. For this one, I've got 2 chloride ions attached to 1 magnesium ion. And the reason why they're different numbers like that, there's different amounts of ions in each one, is because they have different charges. The magnesium has a 2+ charge, chlorine has a -1 charge, and so we need more than one of those chlorides in order to balance those out. So let's come back down here. When we're writing out the formulas, what I like to do is write what the charge is above the name. So magnesium, if we go to the periodic table, is in group 2, so it has a charge of +2. So I'm going to write above that it is +2. Sulfate, you'd have to go to your list. This isn't something on the periodic table. It's going to be on that list of polyatomic ions. So you'd have to go to that list, find sulfate, and you'd see that it has a charge of -2. Now in this case, these both have the same charge, and so I would just need one of each of these in order for those charges to balance. So like if we were to draw a particle diagram, it's like I've got a magnesium ion here, if this represents our magnesium ion, and it has a charge of 2+, and it's going to attach to a sulfate ion, which is SO4, and it has a 2- charge. So I only need one of each of those ions to balance out, because we want to make sure that the entire compound itself is neutral, that it cancels out to be 0. So when I write out what the formula is, I just need to show that there's 1 magnesium and 1 sulfate. Remember that those polyatomic ions, we treat that as like one ion. So that SO4 is like one thing, basically. Let's try the next one. Ammonium, that's another polyatomic ion. That has a charge of +1. You'd have to go to your list to find that one. And then chlorate, that's another polyatomic ion. That has a charge of a formula of ClO3, and the charge on it is actually -2. So that's what you'd see on that list. It would look like this. So -2. Now, to balance these out, since chlorate is -2 and ammonium is +1. By the way, ammonium, I forgot to write that one down. That has a formula of NH4, and it is +1. So I would need 2 of these ammoniums in order to balance out this chlorate, right? I would need 2 of them, NH4 plus. I'd need 2 of these ions to balance out this -2 charge here when they form a compound. So when I write that in the formula, I want to show that I have 2 of them. So I need to use a subscript in there. So what I'm going to do is I'm going to put NH4. Now, what you need to make sure you do is put this in parentheses, and you got to put a 2 on the outside. If you were to put a 2 like this without the parentheses, that wouldn't work, because now what you're saying is that you have 42 hydrogens and 1 nitrogen. But that's not what we're trying to say. We're trying to say that we have 2 of these ammoniums that are attached to just 1 chlorate. So then I would just put 1 of those chlorates, ClO3. So if I've only got 1 of those polyatomic ions, I don't have to put it in parentheses. If I have more than 1, I have to put it in parentheses like that and put however many that I've got. Let's try the next one. Sodium from the periodic table is +1. Sulfide, so it ends in "ide." That means it's sulfur by itself. It's not sulfate or sulfite, which would be SO4 or SO3. This is sulfide, so that's sulfur. On the periodic table, you'd see that sulfur is -2. So I would need 2 sodiums and 1 sulfur for this to balance out. So Na2S. Aluminum phosphate. Aluminum is +3 on the periodic table. Phosphate, which has this, PO4, is the formula for phosphate, and it has a charge of -3. -3. So these balance out already. I just need one of each of those ions. So 1 aluminum and 1 phosphate, PO4. And then calcium hydroxide. Calcium is +2. Hydroxide, which is on your list of common polyatomic ions, is OH, and OH has a charge of -1. So when I write that out, I would need just 1 calcium and 2 hydroxides. So 1 calcium. And then notice I'm going to put hydroxide in parentheses because I need more than one of them, and I need 2. So that's how you would name these ionic compounds, how you'd write the formulas and how you'd write the names. In the next video, we're going to talk about how we do the same thing, but we're going to change it up because we're going to use transition metals, and those use some different rules when we write out those names and formulas.